my name is Fred George. I've been playing with microservices since I did a monolith back in India in around 2004, and I'll never do that again. So I've been trying to figure out ways to get away from that. So I'm going to talk about some of the challenges that I'm running across lately, because having done this for a while now, there's some interesting problems that are arising that I don't necessarily know the answers to. The first challenge deals with how you actually create these services and what they're all about. And it sort of breaks into two camps, the synchronous versus the asynchronous camps. And several of the previous speakers already alluded to this, that the easiest way to sort of attack microservices is take your big thing and tear it to little things and call them to each other, like they were sort of classes or objects. And there's sort of two camps that have formed around this thing, and we kind of agree on a couple of key principles. We both think that microservices are really, really tiny, certainly compared to everything else we've ever written in. I mean, 100 lines of code is a good-sized microservice. We really like the idea that we can write services in different languages, so we can sort of pick the language of choice. And we love the fact that programmers are really motivated to work in this environment because it gives them a chance to play with new technologies at very, very low risk to the organization. And we like to encourage that. And it does allow you to have multiple versions. In fact, the concept, when it was first suggested to me by one of my colleagues that we're going to run three versions of service at the same time, I'm like, you can't do that, it's wrong. And he asked, well, why would that be wrong? I didn't know how to answer that. So it just turned out that running multiple versions is very good because, all the old guys can use the old version, the new version used by the new guys, and that speeds up deployment. So we agree on that. We also agree that it really is kind of hard for programmers who are new to microservices to get their hands around the asynchronous model. They're still thinking about step-by-step flows and things like this, but it's really hard for them to do that. So we agree that's hard. And so it kind of breaks up into sort of two camps. I say Chad Fowler because Chad and I shared a stage in Dublin a few years ago, and we both talked about microservices, and he got up and talked about microservices and the polyglot nature of it. And I did the same, but he was up there basically saying, you should use synchronous as your default model. And you should do that because most algorithms are described to you by your business guys as these are the steps, so it's pretty easy to model that. And programmers really understand that. It can be very productive in that environment. And I'm saying, yeah, but the value of the services is sort of this robustness. The primary goal I have is building a really, really reliable system that can make changes to constantly. And the synchronous nature really kind of messes that up. I really want strong decoupling. I don't want this guy to have to know about my messages and know who to call and where to find them and all this other stuff. I don't want to have to do that. And I might suggest just teach the programmers. Yes, it's going to take a while for them to learn, but let's go ahead and invest in that time and do that win. So that's where we tend to disagree. And I tend to build more assumptions into my asynchronous designs. I have a sort of metaphor for what I think about called rapids, rivers, and ponds. And I drew this as I was flying over the Atlantic several years ago on my iPad because I was playing with a new drawing program. I wasn't very good at it, obviously. But I had this concept of rapids where basically every event is published to the same stream. Every event. Log files, traffic statistics, user journeys, and plus all the messages between the services driven to a common pipe. And it is very much an event-oriented system. It's almost like our operational databases that we used to have in previous designs are now turned into event streams. That is a major architectural shift that supports microservices. And I had the concept of rivers, where you would actually go into the rapids and pull off things that are sort of the same. So it's a little easier for subservices to sort of pipe in to just pull off the river. And there's still a concept of having some static relationships, some current state things. I call these ponds or sort of stagnant pieces of data because they've lost their time nature that the events had. And so using this as sort of our model, I've been designing systems around these sort of concepts. And so basically, in asynchronous systems, I kind of have a model that says, okay, there's a bus and there's a service. And what a service really wants to do is express a need. And he just kind of publishes that into the ether. It says, hey, I have something I need. And I hope somebody's listening. And maybe there's some guys listening. And all they're listening for is this need. That's the only thing they care about is messages that have this need expressed that's been unsatisfied. And they'll publish some answers. Sometimes they'll publish one answer, sometimes they publish multiple. Sometimes they may decide, I don't want to play, and just publish nothing. That's perfectly okay. Meanwhile, the original services is listening for answers to this need. And as they're coming off the bus, he sort of pulls them together. And his responsibility is to choose amongst these options. So this is a basic model and flow that we put together in a lot of our applications as we're getting to asynchronous flows. Because again, the programmers don't really have a working model of how to build such a thing. And we like this because variations of these services is very easy to do. I can go in there to that green service and write green version number 2, which has a slightly different algorithm, plop it on the bus, let it run parallel, watch its performance. If it's better, I keep it. If it's not, I kill it. And by the way, if the purple service goes down, it's okay. The system's still running. It's running degraded, but it's still running. And this is a very powerful thing to claim versus chaining them together. So just to give a sort of example of this, and this is an example I've used with quite a few clients. And frankly, at the end of this demonstration, they're quite horrified at some of these things, which you can see why they get horrified at it. So let's assume I have a car rental agency. It's got a nice home page here and a sort of legacy web server. And I'm going to plop some additional advertising on this page. And I want to sort of do that using this sort of system. So I write myself a lightweight little service to sort of plop these things out. So I'm going to listen to certain things going on this page, like the page being served up at all, and kind of notify something to a bus. Meanwhile, I got a couple of asynchronous services I've plopped up there. I got one that's sort of offering brand level services for the car rental agency. So maybe it's Hertz, and it's like, rent from Hertz, and we have some lovely cars and stuff. But I also have different services for each of the Hertz locations. Because these locations may have different sort of rules and things they want to propose based upon who you are. And again, these two are independent services, written independently, can change independently, and we like that. So we throw a high-speed bus in there like we sort of described before so you can express needs. And there are a couple of other services that actually are sort of auxiliary services in some way. They add additional information into the bus. So based upon who the person is that's signing in, maybe I can tell them about their rental patterns, or the weekend rental patterns, or the weekday rental patterns, because that suggests different sort of offers. Also, I can tell whether they're frequent renters or not. I remember my frequent renter program, or are they platinum? So a couple more services, again, completely independent, sitting there. So, and by the way, each one of these services has their own persistent store. This is where I get some horrified looks from various clients. Like, in fact, I went to one client, a Fortune 100 company, and so I start out with the chief architect, which is also a bad sign they have such a guy. So he's a chief architect, and he said, he sort of say, my leading question is, well, how many databases do you have? He says, well, we have 5 now, but we're really embarrassed about it. We're trying to consolidate them. Well, you really should have 100. You'd have thought I grew fangs right there in the front of them. And every time they saw me after that, there were crosses being held in front of me as I walked down the hall. Yeah, it's a whole different way of thinking about that stuff. So they were horrified by that. So let's go into this model a bit. So let's say Sally, basically a page comes up. That's an event. We're going to publish that event. So it's not a lot of information, but the page is coming up. And a couple of services care about that event. So they're listening for that pattern. And based upon that pattern, the brand will basically say, okay, I have an offer I'd like to give. And so the location guy has an offer he wants to give, and we'll take those offers, and again, the service is listening to them. And you pull them down, he'll find the creatives associated with that, and basically push those to the page. But now it's Sally logs in. So now we know something about this person. It was just a page before. Now it's Sally's logging in. So it turns out everybody cares about Sally. So everybody gets that message. And again, all asynchronous, happening at the same time. The brand has a different offer you'd like to give Sally, and the location also has a different offer they'd like to publish for Sally, so they get published accordingly. But also what's going on is the membership stuff. We know something about Sally. We know that in this case her segmentation information says she's a weekday rental, which she's a road warrior. She's traveling. She probably doesn't care about discounts because her company's paying for it. But an offer that has something like a better car or a navigation system, that may be attractive to her. So anyway, that message also goes to these guys. And now they have more information to make a decision on. They make different decisions. Meanwhile, the stuff about her membership, she turns out she's platinum. So of course that information flows to everybody. Again, more offers get pushed down for that. And so I got some more stuff coming down and being recognized. But now I have actually the segmentation got this message as well. And now, of course, he has both pieces of information. It's Sally and she's a road warrior. So we send that to everybody. And, of course, they have maybe same or different decisions based upon that. But anyway, tons and tons of offers get flowing down here, of which we pick a couple, and we turn those into web views. And of course, now Sally says something like, oh, I need a car in Houston, and let's start this process up again. So you get an idea that in this sort of environment, there are lots and lots and lots of messages flowing. And again, Hardify looks from some of the corporate clients because they're using something like MQ series. And I just used up 5% of their bandwidth on one user. And they're like, well, how many MQ series do we have to have? Maybe the problem is your choice of bus. Make some choices. But this is a sort of design. But again, the recognition and the sort of strange thing is, oh my God, look how many messages we're flowing. Why don't we save some messages? Why don't we use some optimization here? No, don't optimize on this stuff. You can find buses with high capacity. This is not the point you want to optimize. But you can see this is a radically different design. And this is the challenge with moving to asynchronous. This is not the way your programmers are thinking about decomposing their problems. But if you get them into this mode, very, very easy to deploy. So that's our first challenge, synchronous versus asynchronous. And if we choose asynchronous, you got to spend some time, some pain, getting your programs up to speed about this sort of model. Second challenge. This is something I'm running into in practice. It's an area that I'm not particularly qualified to talk about because I don't do this, but it's microservices versus the Clojure environment. Clojure is getting to be extremely popular with a lot of the companies I've been working with lately. In fact, it's been a silver bullet for, frankly, solving some problems. And what really happens is it conflicts with sort of a basic premise of my design principles for services. I design services kind of like the way I design, so I think about OO classes. It sort of has two fundamental principles I was sort of building around as I kind of evolved my thinking. And one is the concept of conceptualization, that every class has one job that it does. And I took that over to services. I want my services to have a job. And if it seems like it has two jobs, it's really two services. I try to tear it apart. And particularly in a Node environment, this is really, really easy to do. It's easy to sort of write a really tiny service. In other languages, the temptation is, let's throw the code where it exists already. I do a workshop where I teach microservice coding, and the first thing everybody does when I do the second part of the exercise is they throw the code back into the original service. Oh, look, I have all the code here. I can do all this stuff. And I say, no, make copies of it. A copy? You want to copy the code? Yes, we want to copy the code. So that's one thing that's sort of different. And the concept of encapsulation is key. That's where I have this separate persistent database with everything. My philosophy is if you're sharing a persistent database between two services, it really is just one service with two APIs. Because you can't really do another version of this service, do an upgrade of this service without sort of going into a data change that coordinates among these things. Well, it kind of sounds like one deployable unit. I want every one of my services to be individually deployable when I need to. So that's sort of how I think about things. And then I come to Clojure. And the whole concept of Clojure, it loves this shared data. We love sharing data because it's immutable. And we have no qualms about sharing data because you can't change it. And so we don't have these race conditions. And we build these really lovely structures that have this, inputs coming into this, series of transforms. And it comes out the other end, and it's amazing what we want to have. And it sort of looks like, okay, I could carve this up in a microservice. Look at these independent functions, run them independently. But then you start looking at the interface between these services. You say, well, what is this thing I'm publishing? Who else would you want to use this map of a hash of a hash of a map of all these massive structures? Who would want to use this? And so the Clojure guys sort of say, no, we really want to package this as one larger service because there's no reason to split it out because nobody else would use this number 2 service, number 3 service by itself. Nobody's going to send me a data structure like this and get an output like this. And so they argue somewhat eloquently that doesn't make sense. And sort of projects I've worked on to date, this has kind of happened to some degree. When I worked at a company Forward here in London, we basically had a service that did some energy calculations for U-Switch, and Clojure was perfect for that. We had all sorts of other services, so it looked like it was a good player then. But then I worked with Clifton, and we started using Clojure, and the Clojure guys, even though we had tons and tons of little node services doing all sorts of amazing things, some of the core engine was done with Clojure with just a couple, and great resistance to try to tear it apart for some of the reasons we just talked about. And then I went to a California startup for about the last year. Clojure is our primary language for that startup. And even though we started out talking about microservices and breaking it up, they're consolidating them now because they feel like, oh, we don't just touch one service, we're changing a series of services in some way. So in some way, Clojure doesn't feel like it's fitting into the microservices world, at least not the way the Clojure programmers are doing it. There is a little hope on the horizon. I'm playing with it a little bit right now, and that's Elixir, which is a functional language that's built on Erlang. And of course, if you're used to Erlang, you're used to hundreds of thousands of threads running independently all the time. So I think I'm going to learn something, hopefully, from Elixir that sort of says, yeah, here's how functional programming and microservices can actually work together. But those are two of the fundamental challenges I'm beginning to see in this world. Again, one, the asynchronous and synchronous, but this move to functional programming, which is a very, very powerful movement. It rivals the node movement and how fast some of these things are happening. I'm not sure how they play with us in terms of how they do microservices. So those are my challenges. If you have some experience with either one of these, I'd love to hear about it in the conference. But that's my story and the two things I'm worrying about right now relative to microservices. Thank you.